Thanks, Kayla. Okay, so let me get this. Try to straighten the video thing up. I don't know that I do this the best way. So I learned something yesterday. Good morning, everybody. I learned something yesterday, and of course, I'm always learning things about how to do things online. But what I learned yesterday is that when I share something like this, when I share a document, that on the recording, that's all anybody can see. So it never switches to me here when I'm sharing a document. So when you watch a recording, if you're hearing me talk, but all you see is a document, then that's because I shared a document. So I'm going to have to be careful with that. And I'm going to have to unshare things whenever I expect the recording to show what I'm doing on the board. So if you guys help me with that, that would be great. So if you see up here, so I'm going to unshare this, unshare Toby. And you can see, hopefully you can see up here on the board. And I don't, hopefully that's big on the recording. I'm still kind of experimenting with this. So anytime you guys watch a recording, if you want to give some feedback about it, that would be very much appreciated. Okay, so this is what we're going to do today. We're going to start with questions. And then we're going to look at the Chapter 1 PowerPoint, which I've also uploaded in Blackboard in lessons in the Unit 1 folder. The in chapter one, it's almost all definitions and what different things mean in statistics. And so that's why I do that as a PowerPoint, because otherwise I'm just writing words up on the board and you're just copying words. And this way you have access to the PowerPoint. Since I've given it to you in Blackboard, I can flip through this pretty quickly and you'll be able to look at it later. All right. And then we're going to do the Chapter 2 skills review, and I have just a few examples I'm going to go over with you on that. Well, actually, I have a lot of examples, but I'm going to do a few particular examples from the homework assignment itself. I'm hoping that that this will kind of naturally break right here, so that we'll do the Chapter 2 skills review when we come back from the break. But right now, let's look at questions that you have. And these could be questions from a homework assignment, although I'm hoping you wrote it down if that's what if you do have a question from the homework assignment, because it's going to be hard for me to switch over to that with the setup that I have. I only have this one device and it's recording for me. So did anybody run into any problems? If you have a question, this can be questions. I would understand if you have a question about the class or about let's see, last time what you should have done for today is you should have done the Chapter 1 skills review. That's the main thing you should have done for today. Did anybody have any questions from the Chapter 1 skills review? We did quite a bit of it, I think, in class last time. But we can do another one or two if you need to, okay? Did anybody have a question? Or about the course? Or have any troubles with my math lab?
Can you go over the please?
The rounding rule. Is there a specific question that we can use to do that, Christina?
Yes, let me look right now. It was...
Yeah, so when you guys have questions or want to ask a question from my math lab, if you would have that on an alternate tab and you can bring the question up for me, that will save us a little bit of time. Yeah.
It was problem 10, but I forgot to write down the actual unit number.
Okay, well, you go ahead. Are you on a computer, Christina?
Yes.
Go ahead and open up a tab over for my math lab. And I'm going to do the same. And if you think it's, so if you can see my face, I apologize for that. I'm actually logging into my math lab on this same device. I had to find the numbers. And I can pull up and see what number 10 is, but you're going to have to give me a minute if I do it this way to,
It is the 1.ir.19.
okay, let me see on that. And it was in the Chapter 1 Skills Review?
Yes.
Okay. And you thought it was number 10, right?
Yes.
Okay, I know you guys, I don't know if you guys can see this or not, but I'm going to write down the problem. I'm looking at it right now. I'm going to write down the problem, then I'm going to come back to you. So what I'm reading is it's saying the population proportion P of members of the XYZ Fitness Center who eat yogurt at least 5 days a week is between 4/11 and 8/11. And that's what my question says. And then it wants you to change those to percents because proportions are actually percents. So this is very much like something that we're going to be doing later in this course. They want us to change these two to percents, and it says round to 2 decimal places. So I'm going to put, so that's the hundredths place. Okay, so I'm going to leave my math lab now. So I'm just curious, while I was doing that, guys, could you see me writing this stuff on the board, or did you see nothing?
I could see you.
Oh, I need to know these things because I need to know what you guys are seeing. All right, so on mine, I was given these two fractions. And so you're going to use a calculator and change these to decimals. Remember, we're always going to go through the decimal as our home base. So, and the way I change a fraction to a decimal is I just do what it says. This says 4 divided by 11. So I'm going to do 4 divided by 11. So 4 divided by 11. And this gives me repeating 3 sixes, okay? And then 8 divided by 11 is giving me repeating 7 twos. So you probably got either a repeating decimal on your, or you may have gotten just a really long, non-terminating decimal. I'm trying to turn my stand here a little bit to make anytime you can't see part of the screen, the part of that whiteboard, you'll need to let me know. Okay, so it says to round to 2 places. So let's look at rounding. So on this first one, I'm going to round that 6 is in the hundredths place, the second place. The only number I'm going to look at to determine whether or not to keep the 6 or raise it by 1 is just the very next number. The rest of those could be 9s, it could be 0s, doesn't matter. You only look at the one number after the rounding place. Oh, wait. They want us to round the percent to 2 decimals. Sorry. We've got to change it to a percent first and then round. They want us to round the final percent to 2 decimal places. I'm so sorry. So we're not going to round just yet. We're going to round after we change to a percent. Because remember, the question was to change it to a percent. So this is moving the decimal point 2 places to the right. 36.3636, repeating percent. Okay, so your proportion is between, and I'm going to write that, this is the way we're going to write it later in the class too. It's between this number and this one's going to be 72.7272, repeating percent. It's the percents that they want rounded to 2 places. So I was rounding the decimal to 2 places. We want to round this percent to 2 places. So the 6 is in the rounding place. The number after it is still a 3. So that means we're going to keep the 6, not round it up. So we're going to put here, this will become 36.36%. So that's going to be the lower bound of the percent. And the upper bound of the percent, we're going to do the same thing, round to 2 places. But the number right after the number in the second place is a 7. That means we're going to add 1 right there. So the upper bound of the percent will be 72.73. 3%. And so the numbers I'm looking for, and I can't remember if they already had the percents written for us. You have to be careful with that in my math lab. If they already wrote the percent for you, you don't want to write it again in the box because it'll count it wrong if the answer ends up with 2% signs on it. Does that answer your question, Christina?
Much.
Okay, terrific. So, and we do a lot of rounding in here, and we do a lot of converting from fractions to percents or decimals to percent. So we need to be able to take a number and write it in any form that we need to. Fraction, decimal, percent, any of those we need to be able to write as any of the others. So it's just different ways to write the number. It's not that you're doing anything to it. It's just different ways to write the same number. So any other questions from the Chapter 1 Skills Review? Okay, then we will go on. Let me erase this. And like I said, Chapter 1 is mostly definitions. And so I grabbed some of the slides from the PowerPoint. I knocked a bunch of slides out. So if you really want to see the entire PowerPoint or the video, or you want to read in the book from Chapter 1, which some of you may find more helpful, then you can go to, in my math lab, go to the multimedia library and choose the chapter or whatever you want to look at, and we'll give you everything. You can also look at my media assignments. So in my math lab, under your assignments, remember the M things? I throw all the media in there. So if you want to see the complete whole picture of it, then that's a place you can go. But for right now, I have pulled up the PowerPoint to share. And we're going to start with section 1.1. And Chapter 1 is an introduction to statistics. And all together, these are the 3 sections. There's 3 sections in Chapter 1. So we're going to look at these 3 sections. Section 1.1 is an overview of statistics. And the very first definition is data. Now, you don't have to write all this stuff down right now, guys. Let's just talk about it. And if you have questions, ask them. Because remember, you can go back and write this stuff down later. You can look at it and get it copied later and take your time. So, but you might put for each one, like just write down the words so that you'll have those and know this is something I need to know. So this first definition is for data. Data consists of information coming from observations, counts, measurements, or responses. Data is usually in the form of numbers, but it can be other things as well. Like your data may consist of, like maybe you're asking different people what their favorite food is, then your data would be food, words, names of food. So they give you a couple of examples here of data. So, but the main thing is just to know data is information that you collect. And what we ultimately want to do is draw reasonable conclusions from our data. When someone says decisions are data driven, they say that at TCC a lot, that all of our decisions should be data driven. That means they look at numbers, they look at information about what's gone on in the past, and they try to make decisions for the future based on that information. Then the next definition is statistics. So that's the class you're in, so you might want to know what it is. Notice it says statistics is a science. I wouldn't say it's an exact science because honestly, different kinds of statistics, you can make it say what you want sometimes, but it really ought to be treated as a science and not interpreted to match what somebody wants it to say. But so it's the science of collecting, organizing, analyzing, and interpreting. And that's kind of the order we're going to do things in. So we're first going to talk about collecting data, uh, and how to organize it. That's how we're going to start. And then later in the course, we'll talk about analyzing and interpreting. Okay. Your data set can be an entire population. Notice it says it's the collection of all outcomes is the population. Now, if you're talking about how many things are in the population, let's go ahead and mention some symbols here while we're doing this, because you're going to have, I'm eventually going to have a symbols quiz on for you, and you'll need to know symbols in order to understand formulas, and you'll need to know symbols in order to do well on the test. So when you talk about the size of the whole population, and the whole population doesn't have to be everybody in the world. It could be everybody in the US, it could be everybody at a particular school, but it's going to be everybody. It's not going to be a random selection of people. It would be everybody within a certain category. Then that's a population. And the symbol we use for this population size is capital N. Then if you randomly select a subset or a part of the population, then that is a sample. And for the size of a sample, you can see that on this one here, this picture that they have drawn, we can see that the sample size is 3. I left the E off. Sorry about that. So that would be little n. So we use a capital N for the population size and a little n for the sample size. So on this picture they have, little n is 3, because that's how many people were chosen. The next definition is the difference between a parameter and a statistic. Both of these are numerical descriptions. So you see here, numerical description, a numerical description, that's what they both are. But a parameter is a numerical description of a population, and a statistic is a numerical description of a sample. So if you're talking about, notice the example they give for parameter, the average age of all people in the United States. Do you see the word all people? That indicates to you that they're talking about a population. And so that average age would be a parameter. And while we're sitting here, let's go ahead and talk about the symbol for that. So we have average age of all people. Since it says all people, that means it is a parameter. Notice, here's an easy way to remember it, that population and parameter both start with P. That's why they underlined those P's. And we have a symbol for a population average. So if I want to talk about population average, the average of a population we use a Greek letter for that one. And the Greek letter, it looks like this. I'm going to write beneath it how to pronounce it. That's mu. And that is the letter that we use. That's the symbol we use to represent the average of a population, is mu. Or another word we use for average is mean. So mu is the population mean. We'll talk about mean in another section. But if you're only looking at a sample, so notice it says on the next one, the average. So we're still talking about average, But notice instead of looking at all of the United States, they're only going to look at 3 states, the average age of 3 states. And here they've drawn the 3 states. Looks like one of them's Oregon. Oregon, what? Maybe New Mexico and what's that state up there? Ohio, maybe? Okay, so the average age from these 3 states. Now we're talking about a sample, and so we're talking about a statistic. So a statistic is a number that describes something about a sample. On this particular one, we're describing the average age. So the average, the sample average or sample mean, the symbol for that is X bar. So let's write how to say that, X bar. And that's one particular kind of statistic. It's the sample mean. You can also have later on we'll learn about other statistics that you can have. And notice statistic and sample both start with S. So if you're using a number to describe a sample, not the entire population, then you're looking at statistics. So since this course is called statistics, that may help you realize that we're really often looking at samples. Ideally, our goal is to take a sample and use the information, the statistics from that sample, the numerical measures from that sample, and extend it so that we can make predictions and conclusions about the whole population. So that's what they're doing, for example, right now on medications that they're trying to come up with to treat COVID. So all they have is samples. They can't try it on everybody all at the same time. So they have sample information, and they're hoping that that information will drive decisions about what they should do for the whole population. Okay, the next thing, there are 2 branches of statistics. I don't ask you questions about this on the test, so mainly we're just discussing things now, okay? And you can look at this later. Descriptive statistics, and that's what we start with, is descriptive statistics in this course. Descriptive statistics involves organizing, summarizing, and displaying. It's just getting the data and saying, here's the data, okay? Then when you try to use that data to make predictions or make decisions, then that branch of statistics is called inferential statistics. So if you're just collecting, organizing, and displaying data, making charts and stuff, then that's descriptive statistics. But when you're trying to draw conclusions about a population, now you're in the realm of inferential. You're saying, okay, those are descriptive statistics. I'm going to use it to infer these conclusions about the whole population. So you see, you might look at something about these 3 people and say, okay, I gave this medication to these 3 people and this is what it did. So I'm expecting this to happen in the whole population. Okay, so that's everything in 1.1. So I'm going to unshare that one. And then we're going to go to section 1.2. Section 1.2 is called data classification. First, we're going to look at some different types of data. The first type is qualitative data. Sorry, I'm having technical difficulties. There we go. Qualitative data. Qualitative data, you can kind of see the word quality in there. Do you see quality almost? These consist of attributes, labels, or non-numerical. That's kind of the important thing with qualitative. This will be on the test, by the way, usually a multiple choice question which says, which of these is qualitative data, or which of these is, the next one is quantitative. So qualitative, notice the examples they've given are major, place of birth, eye color. Notice none of these things are numbers. There is one number though, well, it's a different kind of quantitative. So qualitative are qualities of things, qualities of people. Then quantitative data. And you'll notice that you can kind of see the word quantity in here, and notice it is numerical measurements. So age is a number, the weight of a letter is a number, like maybe the weight of a letter is, 1 gram. That's a number. Temperature, that's a number, like 100 degrees. That's a number. Time is a number, like 2 hours. That's a number. This is all quantitative data. So the next slide shows us some, says classifying data by type. You'll notice on the left, those are words. So that's all qualitative data. Sports-related head injuries. So if you're just looking at the type of injury or the sport in which the injury occurred, you have this. We can see that the most head injuries occur from the sport of, looks like basketball. And so this over here, the actual numbers, that's quantitative data because that's numbers. So here's an example where you could be looking at the qualitative data, which is the sports themselves, or you could look at the quantitative data, which is the actual number of head injuries. Okay, now the next several slides I'm going to show you, you don't need to know. I'm only showing you these so that if you run into a question while you're doing the homework, you'll know where to go to get the answers. So this has to do with levels of measurement. And I'm going to flip through this really fast because I don't test over it, but know that this is here. So if you see anything about it on a question, you'll know, oh yeah, I can go back and look at that PowerPoint and get that information. So we're just going to flip through this and look at this really quick. Different types of measurements are assigned different levels. And the reason why they're called levels is because the higher, there is sort of a lower level and higher level. The higher the level, the more you can do with it. So notice this nominal level is the first level. Notice it's qualitative data only. And it uses names, labels, or qualities. Then they have something called the ordinal level. It can be qualitative or quantitative. And notice you can put an order to it, but the difference in it is not meaningful. Like, so maybe I can't think of an example right now. Maybe we'll see an example later. So this can be qualitative or quantitative, but and there is a ranking or order that you can put them in, but the differences don't mean anything. And then the ratio level of measurement says it's similar to interval level. And I think I must have skipped that one, but I'm going to get to that in a second. Is the interval level on there? Oh yeah, I skipped interval. Let's look at interval. So interval level is quantitative data. So notice those have to be numbers. The numbers can be ordered. The differences between data is meaningful. 0 represents a position on a scale, but it doesn't imply none. Remember, you're not going to be tested over this. I'm just showing you where this is. And then ratio level data is similar to interval level, except 0 means none. That's the only difference. So I wanted to show you this, this chart here first. So if you have a question about this, or like you come across something in my math lab in a question and it asks about these levels of measurements, notice that I have, this lists all 4 levels: nominal, ordinal, interval, ratio. And then you see this is a little chart, and you can see what you can do. You can put the data in categories. On all of them, you can put them in order except for nominal. You can subtract data values as meaningful, except in nominal and ordinal, and so forth. And then there's also these charts at the end of this PowerPoint that gives a summary, and it also gives an example. So this is interesting. So if you look at ordinal level, remember this was one where you could put them in order, but the differences in the order didn't really matter. So here You see, we have, this is qualitative data. This is motion picture ratings, G, PG, PG-13, R, and NC-17. And while I can put those in a particular order, the differences between them is not necessarily meaningful. As opposed to this, and where you could actually find differences. See, you can't subtract G and PG. PG minus G doesn't give you an answer. But if you go to interval level, 32.5 minus 30.7, that gives you an answer. But on this one, it says average monthly temperatures. And when you're talking about temperatures, there is a 0, but it doesn't mean that there isn't any temperature. Okay. Whereas on ratio level, it says average monthly precipitation. And on this one, if you get 0, that means there was no rain. So that's what they mean by a 0 meaning none. And that's the end of 1.2. And guys, don't worry about the levels of measurement. One more time, I don't test over that. So we're going to go to the last section of chapter 1. 1.3. Data collection and experimental design. Kendra, did you have a question? Okay. So data collection, I would like for you to know the difference between observational study and an experiment. We're going to talk about the different ways. Observational studies where you just watch stuff happen and see what happens. It just says, notice observes, hold on, my pen turned off, observes and measures. So you don't do anything to affect the outcome. An experiment is where you do something to one part of it, and then you look to see what the difference in the two groups is. So you might give one group, say you're testing a medicine, and you give one group a certain medicine, and then you give the placebo, which is basically nothing. I think they used to use sugar pills sometimes for placebos, and so an experiment, you actually do something to try to affect the outcome. And an observational an observational study, you aren't actually doing anything, you're just observing. Simulation, and this is something they're using a lot lately, use a mathematical or physical model. You may have seen some simulations showing how COVID-19 can spread when in a group. When one person has it, you can see how it can spread exponentially within a group, and they can represent that with simulations. Another type of data collection is a survey. That's where you ask people stuff. Notice usually commonly done by interview, internet, phone, or mail. A survey is not a great way usually to collect data because not everybody will answer. Then a couple of interesting things, but things I don't test on, is I think this is interesting, but I won't ask you anything about this on a test. Confounding variables, it says, occurs when an experimenter cannot tell the difference between the effects of different factors on a variable. So it says, for instance, a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If the business at the coffee shop increases, they may not necessarily know whether it's because of the remodeling or because of the new mall. So that means that the new mall was a confounding variable and makes it pretty much impossible to tell if the remodeling had a positive effect. Another possibility, this one is the placebo effect occurs when a subject reacts favorably to a placebo when in fact the subject has been given a fake treatment. So like someone thinks that they received a medicine and so they think they've gotten better, and that's a placebo effect. I don't test over this. So these last few things, guys, are just kind of interesting things in statistics, but not some stuff that I test over. Then there's a couple of things here about like this is kind of interesting. Blinding is a technique where the subject doesn't know whether they're receiving a treatment or a placebo. And double blind is where the subject doesn't know and the experimenter doesn't know either, so that the experimenter doesn't know who's getting the real medicine and who's getting the placebo. And that would be a double blind experiment. Something that's really important if you're going to design an experiment, something that's very important is the sample size. So like if you give a medicine to 3 people and they all get better, that seems to mean you can't just assume that means that that medicine works for everybody. That sample size is way too small. So sample size is really important. And so one thing that's important before you draw a conclusion is to do something called replication. And that's where you repeat the experiment using large groups of subjects. This is especially important when you talk about vaccines. So I thought this was an interesting example that they had on this, very appropriate for our time. It says to test a vaccine against a strain of influenza, flu, 10,000 people are given the vaccine and another 10,000 people are given a placebo. It says because of the sample size, the effectiveness of the vaccine would most likely be observed. In other words, this is a lot of people, and so you should be able to tell how effective the vaccine is from this sample. And then if you determine that it was effective, then you may want to replicate that experiment again, just sort of as a backup insurance to guarantee that that vaccine truly works. Okay, so the things about experimental design, I don't test over. But now we're coming to something that I will test over. So you might write down just the main things. Not this one, but when we talk about when we talk about the different types of sampling techniques, you'll want to write some of those down. So here, one sampling technique is to take a census. This is a count or measure of an entire population. We're currently in the middle of a census. It's funny how many of the definitions in this are really applicable to what we're going through now, because we're in the process of a census right now, because it's a decade. It's the end of a decade. It says a sampling is a count or measure of part of a population. And you commonly use sampling because it's often hard to look at the entire population. Notice this next thing. Even with the best methods of sampling, a sampling error may occur. A sampling error is the difference between the results of a sample and those of a population. Meaning sometimes something happens in a sample, but for some reason, it's not representative of what will happen in the population. So what we're going to look at are some other types of sampling techniques. And one of the things we want to make sure we do is always get a random sample. So if you are collecting a sample, you want that sample to be random, because you don't want it to be biased in any way. So in a random sample, every member of the population has an equal chance of being selected. In a simple random sample, every possible sample of the same size has the same chance of being selected. And there are lots of ways to get a simple random sample. So here's some ideas. Here's some examples of how to get a simple random sample. So you could you can generate random numbers different ways using a random number table or a software program like Excel, or you can use calculators will give you random numbers, and then you have numbers assigned to people. And so say I got my calculator to give me 3 random numbers between 1 and 20, and it came up with 2, 10, and 17. Then the people with those numbers, they would be my sample. Notice it says assign a number to each member of the population, and then the members of the population that correspond to those numbers become members of the sample. So a simple random sample generally involves assigning random numbers and then choosing numbers out of a hat. You could also choose names out of a hat. Like I could take all of you guys, put all your names in a hat, and say I wanted to create a group of 3 people to study something. Then I could randomly pull 3 names out of the hat. That would be a simple random sample. At the end of this, they're giving here an example of using a simple random sample. So this example says there's 731 students currently enrolled in statistics at your school, and you want to form a sample of 8 students to answer some survey questions. So select the students. So how do you select those 8 students? Randomly. So it says assign numbers 1 to 731 to each student, and on the table of random numbers, choose a starting place at random. It says, suppose you start in the 3rd row, 2nd column. So I'm going to show you what a table of random might look like. So that said 3rd row, 2nd column. So here's the 3rd row, 2nd column. It says, read the digits in groups of 3, ignore numbers greater than 731. So they decided to take the first 3 numbers and they randomly selected this as a starting place. So the students assigned numbers. Notice they did 719, and then they went across that row. So they're going this way, guys. They're looking at this row. So on the second one, it looks like they chose, they looked at 738. That was too big. On the next one, they picked 4. And 662 on, oh, I see what they did. They just divided it into 3s. Okay, so they did 719, then they did 662, then 738, then 650, then 4. And we're only going to keep the ones that are less than 731. And then they chose 53, and then they chose 589, 403, 129. And you just keep going until you have 8 that are less than 731. And that's one way to get a random sample. And there's all kinds of random number tables that you can use like this. Okay, that's kind of a complicated way to get a sample, but it's doable. Let's look at some other sampling techniques. One sampling technique is getting a stratified sample. I will want you to know what this is. Notice for a stratified sample, you divide a group into groups or strata, and they should be non-overlapping. Like age groups. Age groups can be strata. So notice here what they did on this particular example is they did, their groups are based on income. And those would be defined in some way. It says to collect a stratified sample of the number of people who live in West Ridge County households, you could divide the households into socioeconomic levels. And then notice what they're doing is depending on the size, notice I chose 2 people from group 1, 2 people from group 3, or 2 households, I should say, and 3 from group 2. Now, the reason why they might choose 3 from group 2 is because if group 2 is way bigger than the other 2 groups. So it says divide a population into non-overlapping groups, and then you select a random sample from each group. And when you select that random sample, you do that kind of like that last thing, like you might assign them numbers, or you draw them out of a hat or something like that. So sometimes you really use more than one thing. Okay, something that's kind of similar to stratified sampling is cluster sampling. Except with cluster sampling, you're dividing the population into groups. That's the same, but it's really based on location, not on qualities. So here it says you can divide the household into clusters according to zip codes. If we were in a classroom, I could divide you into clusters by rows, and I could say, okay, everybody in row 1 is cluster 1. And then what you would do, then it says, then select all the households in 1 or more, but not all of the zip codes. So in this case, they divided it into 4 zones based on location. Those are your clusters. And then you randomly select one zone. So they randomly select zone 1. And the way you would have randomly selected that zone is maybe put the numbers 1 through 4 in a bag and draw one out. And you can go over this later, guys, if this is new to you, and I've got this PowerPoint available to you in Blackboard in the Unit 1 folder in Lessons. Another sampling technique is systematic sampling. This is one of my favorites. So you you choose a starting place at random, and then you choose every kth member. So that can mean every third or every fifth. So on this example, they randomly started with this number, 86. Maybe that's their address. And then it said they're going to select every 100th household. So in this case, your K is 100. Or say you had that job of asking people questions in the mall. Maybe you randomly pick one person to start with, and then after that, you ask every 10th person who walks by. That would be systematic sampling. Then I think this might be the last sampling technique that you should know about, and that's a convenience sample. On this, you choose only members that are easy to get, and this often leads to biased studies. And a convenience sample would be like when they used to have phone books. If you were calling people from a phone book, those are easy to get, but that often leads to biased studies because the only people you're going to get to answer you are the ones who answer a phone from an unknown person. So, or maybe you send a survey out by mail. That's pretty convenient and pretty easy, but that's kind of biased because only, maybe a certain type of person reads all their mail, that sort of thing. At the end of this PowerPoint are some examples about how to identify sampling techniques. So I'm going to leave this example up for you to look at and see if you can figure out why it is the way it is. And I'm going to check roll while you're looking at this example. So when I call your name, please raise your hand and leave it up until somebody's name called. Layla, do you have a question?
No.
Okay. These definitions, this isn't a lot of fun because it's just information. That's why I didn't want you to try to write all this down. Just go back and look at this again and make sure you know the difference between the different sampling techniques. Okay, so when I call your name, raise your hand and leave it up. Ariana Saavedra? Ariana, are you there? Raise your hand. Thank you. Cecil Leonard? Diamond Bivens, Jacob Lee, Kayla Hernandez, Kendra Tarver, Christina Cameron, Layla Goldsmith.
Here.
Can you raise your hand? Do you see the little raise your hand thing at the bottom left? There you go. Thank you. Mia Campos, Natalie Ramirez, Samira Arvizu, Stephanie Garza, Temperance, Tori Banks, Vanessa Pacheco. Is there anybody here whose name it looks like I see all the hands up. Okay, you can put your hands down. Thank you. Before we break, so we'll take the break at 11:30, but let me tell you a few things before we take the break. I'd like for you during the break today, so I'll always give you an assignment. Here, I'll put this up so you can see me instead of looking at this. Hold on just a second. Okay, let me move that over. And I'm going to stop sharing this, otherwise people won't be able to see this when they watch the recording. So during the break, and remember our break is from 11:30 to 12, and during our break, I would like for you, you can look over this PowerPoint if you want to, but the big thing I would like for you to do is go to my math lab. If anybody has not created their account yet, I want you to do that during the break. If you need help, I will be here during the break and I will help you as best I can. Those of you who already have accounts, go to my math lab, and what I want you to try is you can do this chapter 1 if you want to, the chapter 1 homework. But what I'd really like for you to do so that I can answer all your questions, I'd really like for you to do the chapter 2 skills review. You may not know how to do all of it. I haven't talked about it yet, but I'd like for you to flip through it so you'll have an idea of questions you definitely have so that I can be sure to cover those questions. If you flip through it and if you don't know how to do any of it or don't remember how to do any of it, that's fine. Then just go back and work on the chapter 1 homework. So the chapter 2 skills review has a Q in front of it. And so work on, if you haven't registered for my math lab, so this is what I want you to do during the break today. Register for my math lab if you haven't done so already. And the instructions for that are on my ICR, which you can find on Blackboard, my TCC. And look at the ICR and our syllabus. And the instructions for registering for my math lab are in that ICR, including the course code. Everything's there that you need. And if you've already done that, which a lot of you have, then try this. If you don't know how to do any of them, that's okay. Then go to this. And I think you're going to find this is pretty easy, which is why I'm kind of thinking you should wait to do that, about those definitions we just went over in the PowerPoint. So during the break, get a drink, get a snack, take a break, but also do one of these 3 things. And then we will get back together at noon. Remember, we have the second part will be from 12 to 12:30. And during that part, I will be doing examples from this chapter 2 skills review. So that's what we're going to do after the break. So it looks like we can break a little bit early. So if any of you have a question, I'd be glad to answer it. Kendra, I see your hand is up. Do you have a question or do you just leave your hand up? I'm sorry. No, I'm sorry I didn't catch that. Let's talk during the break, Kendra, okay? And I'll answer your questions then. So if the rest of you don't have any questions, then take your break, work on one of those three things, okay? Anybody else have a question? Kendra, I'm going to work with you, so hold on. Okay. All right. So let's try to work on the question that you have, Kendra.
Can you hear from the interpreter?
I can hear you a little bit, not great.
Okay, so the interpreter doesn't have access to the Blackboard right now. So I'm using Zoom's microphone to talk to Kendra's computer.
Okay. Yeah, let me turn my microphone up a little bit. I don't know if it will help or not. I can just barely hear you.
Can you hear me now?
Yeah, it kind of waves in and out for some reason.
Okay, so what's happening is the interpreter doesn't have access to Blackboard.
Okay, is something my understanding is that the interpreter would get access to Blackboard. Is that true or not?
I didn't catch that either.
Oh, I'm contacting somebody, I think Olivia. I think Olivia is it? I was contacting someone. I tell you what, Kendra, I'm gonna write my, oh, you can't see I'm gonna put my office number in the chat, okay? And then give me a few minutes to get downstairs and the interpreter can call me on the chat. Okay, so here's my office number. And if that doesn't work, if that number doesn't work, if it goes to voicemail, then please email me with your phone number and I'll call you. Give me a couple of minutes to get downstairs. I'll taking you with me. Okay. So I'll let you know when I'm downstairs so you can call. Okay, Kim. So, and I'm going to turn my mic off if once I get the phone call.